Hey again, it's Mr. Lum, and we're going to be talking some more electrochemistry, and we're going to be looking at predicting the spontaneity of redox reactions. Okay, so right here what we have is we have this table, and this table is standard reductions potentials of half cells. So we have a bunch of different reactions right here. And we're going to see how we can tell if a reaction is going to be spontaneous or if it's not going to be non-spontaneous. Okay, so again, this table, if you look, and I know it's very, very small, you're going to have to look at your own data booklet table that you should have, and what you should see is that these are all half reaction kind of things. Okay, so the forward reaction, it is all gaining electrons. So this very top one says F2 plus 2 electrons makes 2F. So since it's gaining electrons right here, okay, gaining electrons, it is a reduction. Okay, remember Leo says gaining electrons is reduction. So the forward reaction right here gains electrons and it's reduction. Okay, since it's gaining electrons or it's reductions, it's an oxidizing agent. Remember, or. Okay, oxidizing agents are reduction. Now the reverse reaction, F minus, what happens is that it loses 2 electrons and becomes F2 and 2 electrons. So remember, losing electrons is oxidation. And that's why on this side we have reducing agents, and on this side we having oxidizing agents. Remember, oxidizing agents are reduced and reducing agents are oxidized. Okay? So let's talk a little bit more about this table right here. So at the top of this table, okay, at the top of this table, we have very, very strong oxidizing agents. So these are very, very strong oxidizing agents. Or in other words, we have things that really, really want to reduce. Okay, so I wrote that here. Increasing tendency to reduce is at the top of the table. They really want to gain electrons at the top of the table. Okay, and that's why we see on our table it says strong oxidizing agents. Okay. Now at the bottom of the table we have strong reducing agents at the very bottom of the table. Okay, or in other words, since they're reducing agents want to be oxidized, we have an increasing tendency to oxidize is at the bottom of the table. Okay, and again, increasing tendency to oxidize at the bottom of the table, we are talking about this side of the table, the reducing agents. Okay, and when we talk about things that want to reduce, we're talking about the oxidizing agents. Okay? Anyways, let's move on to the next slide. Okay, so how to tell if something is going to be a oxidizing agent or which one's going to be the reducing agent. So let's take an example of, say if we have this right here. Say if we have Ag plus an electron and makes Ag. Okay, and we have something like Cr3 plus an electron makes Cr2 plus. Okay, so let's find this on that table, and I've zoomed in here onto that table and we found it. Here is the one right here, and here is another one right here. Okay, now we also see Cr3 plus right here, but it makes Cr solid, so not this one. We're going to be dealing with this one right here and this one right here. So what we should do to see how is this reaction going to play out when we react this one with this one right down here. First, we should see which is the better oxidizing agent. Now, the better oxidizing agent is the one that is higher on the top, okay? Higher on the top on this side. Remember, on this side are the oxidizing agents, and this side is reducing agents. So see which is a better oxidizing agent? Well, it is this one right here, Ag+. Ag+ is the better oxidizing agent. Okay? So our reaction is going to be Ag+. Now our better reducing agent is going to be, remember if you remember that, if you're looking at your table, this way is the stronger reducing agent down here. So this is for stronger reducing agent. And the stronger reducing agent is, well, Cr2+ is the stronger reducing agent. Okay? And so this is how our spontaneous reaction is going to be. Since this one's a better oxidizing agent, it wants to gain electrons more than anything else here. Okay, Ag+ wants to gain electrons more than everything else. And Cr2+ wants to give an electron or lose an electron more than everything else. Okay, so that's why they are on the reactant side. And they are going to make, well, we just follow this, we make Cr3+ and Ag solid. Okay? And this is our spontaneous reaction. Okay? So how we choose it is, I know we took this reaction, we kind of flipped it around, but since this one is our strongest oxidizing agent, and this one, of the ones that we're dealing with in this example, is our strongest reducing agent, these two are going to be our reactants. Okay, these two are going to be our products. Okay, and we're going to see a trend very soon. Okay, now, so this is our spontaneous reaction. Let's write that down. Spontaneous reaction. Now, if you had something like this, Ag+ and Cr3+, well, these are not going to react because these are both oxidizing agents. Okay, so that means they both cannot gain electrons. Okay, so this would be no reaction on this one. Same thing if we had this one, Ag and Cr2+. We can't have two things that are going to be losing electrons. So if we had Ag and Cr2+, okay, these ones are not going to be reacting either because these are both wanting to lose electrons. And that's not good either. Now, this one, if you had Ag and solid and Cr3+, this this could possibly react, but it's not going to be spontaneous. Okay, this one could gain an electron. This one could lose an electron, but you know, if they do, then they're going to become this, and this reaction wants to spontaneously happen this way. So this reaction could happen, however, it is not spontaneous. It's a non-spontaneous reaction. Now, we're going to talk a lot about non-spontaneous reactions later, but what a non-spontaneous reaction means is that, yes, it could happen, but it's not going to happen by itself. It's not going to happen spontaneously. It's only going to happen if I add a lot of energy to it. Okay, and we'll talk about how much energy we have to add, but that'll be a little bit later. Okay, let's move on. So, again, spontaneous reactions. Now, here's an easy way to remember it if you have this whole table right here. If you draw a line between one compound, okay, or one species, say like, I don't know, we'll just pick one, just randomly, this one, and you pick another one, this one, you draw a line. If your line is this way, it is spontaneous. Okay, so spontaneous reactions are going to have a line that kind of goes like this. Non-spontaneous reactions are going to have a line that goes like this direction. Okay, so non-spontaneous is going to have one like this. So spontaneous is going to be from top left to bottom right. Non-spontaneous is top right to bottom left. So again, spontaneous, non-spontaneous, spontaneous, non-spontaneous. Okay. Please be careful. There are some ions that are on both sides of the table. So you're going to have to be very diligent and look at this whole thing quite thoroughly. Okay?